Hi everyone. So I'm going to present this topic is about the convolutional neural network. So convolutional neural network is just something that is enhanced from convolutional neural network. First let's talk about the convolutional neural network. For short, we will call it CNN. So it's really simple. The convolutional network mostly consists of these four layers. So the first one is convolutional layer. The second one is pooling layer. The third one is activation layer, and the last one is dense layer. It can consist of other kinds of layer like recurrent layer, for example. In this example, we don't have pooling layers, which is possible as well. So this is the first convolutional layer, and this is the second one. This is the third one, and then followed by two dense layers. Okay, so this layer has 8 filters, and each filter has 64 by 64 filters or kernels, and this has 24 filters, and each filters has 48 by 48. All right, and so on. And this dense layer has 256 neurons, and so on. Okay. Okay, this is CNN. So the CNN is very popular for image processing, for example, object recognition or image classification. So the state of the art is, for example, ResNet, um, Inception, Exception, or VGGNet. All right, so let's go to the next one. So the second one that you need to know for this presentation is adversarial examples. So adversarial example is just the samples that can mislead the target classifier such that the output, the prediction is contrast with humans' perception. For example, you can see this image is a panda, right? So at first, the classifier classified this panda with 57.7% confidence. But when we add some we compute some like adversarial perturbation and add to it. This is the result. It looks the same. It's still panda, but the classifier classified this panda as a gibbon with 99.3% confidence. So this is the adversarial example. So we can find a lot of adversarial example for a classifier, for a targeted classifier. Okay, so now let's go to the detail of the paper. So this is convolutional neural network. So the name is quanvol, right? Which means it's about quantum. Okay, so this is the example of convolutional layer. So convolutional neural network, it is just the CNN or convolutional neural network with a convolutional layer. This this exists in this work in 2020 by Henderson. It's really interesting. All right. So this is a convolutional layer. It works like convolutional layer. Let me explain this step by step. So first, it has five quantum circuit, right? Which means it has 5 filters, and each filter is gonna get the kernel from the image to this rotation gate in quantum gate. Y, okay, Y. All right, and so this kernel will times with the angle of this gate, and it will rotate this direct notation of 0, and after that it's gonna go to random circuit. So random quantum circuit. So the entanglement and all the thing that perform that be performed for spatial correlation for each kernel, and the output will be measured here, and then we will for the average for the um for all the bits in the kernel and result to one bit of the result. We compute the average of all of 4 bits. In this case, it's 2 times 2 kernel, right? So there are 4 bits. There are for information for data. So we compute the average of it, and it's gonna be pushed to one information in the output. Okay, and we have 5 filters. So as a result, we will have five results, 5 outputs. So it's just like convolutional layer, right? But we use quantum circuit instead. And we found that as a result for the convolutional layer, you can see here is this input, right? And this is the filter, each filter of the convolutional circuit. The result is right here. So you can see, for example, 5, the first filter can focus this on different part of the image. You can see here, and you can see 0 here, different part of 0. So we can say that, okay, the convolutional layer can actually extract the feature from the image very well. All right, very well. So let's see the experiment and the result. The dataset that we use is MIST, which is the handwritten digit images. It's very simple. It's very common in image processing, but we use only 50 training images and 30 test images because it takes a lot of time for quantum layer to be computed in the classical computer. And the models that we use and train is linear model, quantum. The linear model is just linear classifier. It's like neural network, which is just one layer. Um, okay, one input layer and one output layer. Okay, and quantum linear layers is that it's just a linear layer with additional quantum convolutional layer at the front. And CNN model is just a linear model and the convolutional layer at the front. And quantum CNN model is just a CNN model with the quantum convolutional layer at the front. And 2 CNN model is a CNN model with another CNN convolutional layer at the front. So these two models have the same number of layers. Okay, these two models, the quantum CNN model and 2 CNN model, so that we can compare with whether convolutional layer is better than convolutional layer. Okay, and for the robustness, we use Kalinian Wagner attack to generate adversarial samples. Here, this is a good paper. You may check it out in the reference. It explained very well about the adversarial samples. So the first one we're going to talk about the accuracy. So these two figures is a comparison between the linear model and quantum linear model. You can see when we add the convolutional layer at the front of the linear model, the accuracy, we gain more accuracy than the linear model, and we gain less loss than the linear model. Okay, the blue line is with convolutional layer, and the green line is for without convolutional layer. Okay, and the second row here is a comparison between CNN model and quantum CNN model. Okay, we have the same result as in the previous one, that we add convolutional layer and we get the better result. But these two rows is not fair, right? You may notice it because the quantum CNN model and quantum linear model have more layers than the CNN model and linear models, right? So to be fair, let's see the last row here. In the last row is a comparison between 2 CNN model and quantum CNN model. Okay, but even though they have the same number of the layers, um, it achieves the same accuracy, but the quantum CNN model achieves the lower loss than the two CNN model, which means that convolutional layer can produce less loss than the convolutional layer, which is we got a better result with the quantum layer. All right. So next, the robustness. You might be confused. Let me explain this figure. So the x-axis here is just the target model. All right. Oh, sorry. Is this x-axis is the model that we will evaluate, and each color here is the adversarial examples that are generated from the the each model here. For example, the blue line, the blue color here is the adversarial examples that are generated by using linear model. The orange here is the adversarial examples that are generated by quantum linear model. The green color is the adversarial examples generated by CNN model, and the red color are adversarial examples that are generated by 2CNN model. Okay. All right. Let's see the result. So the y-axis is the accuracy score. You can see here. So okay, linear model is affected a lot from the adversarial example by itself and also by other models as well. But you can see with the quantum layer, it is more robust. You can see here the adversarial example, the colony and Wagner attack cannot harm the quantum linear model at all. It seems like it cannot find the way to um to to reduce the loss of the quantum linear model. It doesn't. I think it doesn't reduce the loss at all, and the adversary from other model is don't impact a lot on quantum linear model. Similarly, on quantum CNN model, it had the same result as well. Okay, because you can see here, it can achieve higher accuracy than CNN model. All right, and also in this one, it can achieve higher accuracy than two CNN model for the adversarial example generated from two CNN model. Which all right, and we can conclude this everything with this one. So with the convolutional layer, we can make a convolutional neural network gain more accuracy and robustness. And also we find that the convolutional layer can reduce the loss better than convolutional layer, right? In this figure, okay? And also we also find that the Kalani and Beckner attack cannot find adversarial samples on this convolutional layer at all. Okay, at all. It seems like convolutional layer um remove all the perturbation from the images. Okay, and these are the references for the papers that I have mentioned in the presentation. So the first one is a very good one. They explain very well about the adversarial sample and how to perform adversarial training to protect the classifier from adversarial examples. But it's just the early stage for the defensive mechanism. This is so this the second paper is use the optimization approach to create adversarial sample, which is so the adversarial samples in this paper is considered as the strongest one, right? Okay, is also a good paper, and this paper is good to it's good to explain about the convolutional neural network and how it works in detail. So first, if you want to know about adversarial sample, I recommend you to read this paper and then read the second one. Okay. All right. Thank you.